My name is Mohan Varthakavi. I'm a senior manager at Amazon ElastiCache. I've been with Amazon for the last 7 years, with the service team for the last couple of years. This is my fourth reInvent. Exciting time for us, particularly we are representing the service team. In fact, this is the time for us to actually talk about all the things that we have done throughout the year, and so very exciting time for us. And I have Ravi Kumar Balachandran, who is also part of Amazon ElastiCache engineering, and we together we're going to talk about Redis and migrating if you have workloads, Redis workloads on EC2, and some of the considerations that you should definitely think about. First of all, before getting into the presentation, though, how many of you actually are first-time reInvent participants? Oh, nice. At least half of the team. We have very few, but even half of them are first-time reInvent. I hope you're enjoying. When I was in reInvent for the first time, it was a bit overwhelming because so many customer meetings and a lot of learnings, insights from customers. And so it really helps us, and I'm hoping that you're enjoying it. Looks like there are parties going on in different casinos, and I hope you're enjoying that as well. With that said, today's session is about Redis. We're going to talk about what is Redis and why does it matter. We're going to talk about why you should use Amazon ElastiCache. We're going to talk about how you can migrate Redis workloads from self-hosted EC2 to Amazon ElastiCache. We have a demo, and then we have question and answers. And so our hope is that by end of the presentation, you have a few things, action items. If you're particularly running Redis on EC2, that you could actually use our considerations to move it to ElastiCache. And so that's our goal. With that said, I just wanted to talk to all of you and about familiarity of Redis for you. How many of you are actually either brand new to Redis or probably less than a year learning about Redis? We have a couple of them, 3. So you're learning about Redis and looking to use it in workloads. Suppose that's the situation you're in. How many of you are like 5 years or maybe more than 5 years as well? Okay, so we have 3 or 4 experts. So awesome. How many of you are 10 plus years? This is a trick question. Yeah, okay, nothing surprises me because Redis turned 10 years only early this year. So a handful of people actually used Redis for more than 10 years, and so probably Salvatore, who wrote the product. Good. So I'm going to talk about Redis really quickly for the people who are new to Redis, and I'm going to talk about ElastiCache, and then we get into the migration stuff. Redis overview. Real-time applications. Most of the applications you use today in this, like on your mobile phones, desktops, and whatnot, because of the network speeds and bandwidth that you can communicate with and all of that, you typically have requirements where your response times have to be really, really, really fast, and it should be in real time. And many of the applications out there, they're looking for providing seamless experience for customers. Typically, they're dealing with terabytes of data and sometimes petabytes of data. But you're talking about latencies less than even a millisecond. We say microsecond is the normal. So some of our workloads where latencies are like 300 microseconds. And so you're talking about really extremely low latencies. And also applications need high throughput as well. We're talking about millions and millions of transactions per second. And developers who are looking to develop these applications, they're looking for something that's open source, so they're familiar with, instead of learning some proprietary APIs and whatnot. And so it's important that the API is friendly, developer friendly, and it's kind of something that developers can easily connect to and develop. Now, and there are several use cases. Caching is one of the big use cases. Majority of our workloads, actually 70% of them are caching workloads. And customers are looking to use a cache either sort of in front of their primary data store or as a temporary state of data to achieve high performance. There are other use cases as well, like leaderboards, gaming use cases, media streaming, several of these scenarios. They are all real-time applications looking to get very high throughput and low latency. Now, this is where Redis comes into the picture. Redis is an in-memory data store, has been 10 years, like I said. And the idea is that because you store the data in memory, you can actually provide very fast response times. You could achieve low latencies and high throughput with the data that is stored in the memory, obviously faster than retrieving data from the disk. It's open source, simple. It's designed for high availability because it has the topology like masters and replicas, where if you have a master, you can replicate data real time. And most importantly, it provides several data structures that developers are sort of familiar with. When I was a developer, I was using lists and still writing code at the time, like sorted sets and things like that, right? If I have a data store where I can actually see the same type of data structures that I can actually store and retrieve data, it's easy for me to connect to. Redis provides very rich set of data structures for your consumption. The other important factor is that Redis provides set of commands that you can use to make your implementation easy. Like for example, when I was in my previous stint, I was in geospatial, and one of the things that we used to do was finding a nearby restaurant, for example. And for you to do that, you will need to write complex code to say, here is the bounded rectangle, and then you write complex code to say this point falls into that rectangle and proximity things and all of that. And there is a simple one command in Redis called georadius that just does all of that for you. You just need to add lat longs, it does all of that for you. So set of powerful commands and all of that. Most importantly, it also provides you the backup and restore. So if you have data that you want to take backup, and if you want to launch a new instance with that data, you can do all of that. So Redis is extremely popular. Stack Overflow, that's where developers go for collaborating on difficult issues and things like that. And so 3 years in a row, Stack Overflow in survey, they voted Redis as the most loved database 3 years in a row. So it's extremely popular in developer community. Now you must be thinking, if it is open source, why can't I just put it on EC2? Why can't I just run it myself, right? First of all, to run Redis, it's important to configure that in such a way that it does the right thing for you, particularly optimizing for a use case. Setting memory settings and setting it up, making sure you are designing the right topology and all of that, right? So that takes time. It's difficult to manage that. It's also making sure it's highly available is an important consideration. Redis runs in several modes, cluster mode, non-cluster mode. Even in the cluster mode, you can have 2 shards where there is no majority, and a few other aspects where your typical having a master and a replica is not going to provide you high availability. You need a sophisticated monitoring system that can look at the nodes that is running Redis and take appropriate action when the nodes get impaired and also when nodes are not responding. That's also difficult to do if you're doing it on EC2 on your own. It's difficult to scale. Many of the times for real-time applications, one of the things that changes rapidly is your transactions per second. A lot of times you don't have a leading indicator. in terms of when you're going to get more volume of requests. And many of these situations you want to scale out, meaning you want to distribute your data across multiple masters or shards, and so you get incremental write throughput, and or you want to scale up, and so you can get incremental read and write throughput. And so scaling out, scaling in, all of these things, doing it in an online fashion is also very difficult to achieve. And so if you're hosting on EC2, you have to do all of that stuff. Because of all these reasons, it gets very expensive. You're going to invest resources and time to do all of this. Instead, you can actually use your resources on things that really matters to your customers and enhance your product experience. And so this is where Amazon ElastiCache comes in. As you know, at AWS, many of our services that we created and we provide to customers is because customers actually asked for it. We get many of the roadmap items for us from customers. And so at the time when we actually released ElastiCache, we started with Memcached, and then we released Redis. This was almost 7 years ago. Many of the customers actually asked for it, and they said, look, we are using EC2, you provide a great platform, compute platform with several instances and all of that, but we are spending time on all these things that you can make it easier for us. And so that is when we came up with ElastiCache. Now, what do we do on ElastiCache? The first thing that we do is that we are tuning Redis for extreme performance on the instance types. Take R5s, for example, or M5s. We released early in the year our R5 and M5 instances that you can use to host Redis workloads on ElastiCache. And on ElastiCache, you can achieve 150% incremental throughput compared to your open source Redis. On a single node, on our biggest R5 nodes, you can get up to 425,000, almost 500,000 transactions per second. That's amazing. And what we're doing is that we're really working with EC2, and we're really tuning both at the network stack level and at the VM level to make sure Redis performs and provides incremental throughput for customers. And then we also provide you fully managed experience. What that means is that we are taking care of everything for you, meaning we're patching the nodes, we are configuring the right way. We have a sophisticated monitoring system that's actually monitors the nodes and your cluster all the time. And we take action immediately when we find a node that's not healthy or not responding. We also makes you scale your cluster easily, both scaling out or scaling in, or scaling up and down with new instance types, and you can do that many of the configurations in an online fashion. You don't have any downtime involved in that, right? And we provide multi-AZ support. What that means is that if you have a master and a replica in different availability zones, in rare cases when your availability zone is experiencing issues, we can fail over your master to the alternate availability zone, meaning that you don't have any downtime. Most importantly for enterprises, this is very important. We are secure and compliant, meaning that we are HIPAA compliant, PCI, FedRAMP, and we take care of all of that. When we have a patch that we need to patch your nodes, we either make you select when you want to patch, or we do it for you in the maintenance windows that you prefer. And so your cluster is always compliant with whatever the regime that you chose. And most importantly, we are open source compatible, meaning that anytime we have open source version, within a few weeks of the release, we have it available in ElastiCache as well. So that's the ElastiCache story. A lot of our customers actually are very happy using ElastiCache, and we have some big customers to mention. Expedia, as you know, is analytical for their analytical workloads. They use ElastiCache as a caching layer. We have Grab as well, which is a ride-hailing application. They use it for caching layer as well for their data computation in real time when people schedule their service. Everybody knows Fortnite. Probably somebody in your family play that game. Epic Games, which is the producer of Fortnite, they use ElastiCache as well for session store. You're nodding, so probably a few folks using Fortnite. GE. GE is interesting use case, particularly GE prediction platform. What they have is that they have container workloads, and so they're spinning up these new containers all the time, and it's a serverless application. And so the idea is that they still have some session state that needs to flow between container to container, and they use Redis for the same thing. So we have several other customers in all kinds of categories, geospatial, financial applications using ElastiCache as well. With that said, let's talk about how many people actually are hosting Redis on EC2 in this group. 1, 2, 3. Okay. So let's talk about migrating your workloads to ElastiCache. And let's talk about the very basic one that you can do. If you are hosting on EC2 and if you can take downtime, and if you have a primary data store that's backing up your Redis cluster, then one of the things you can do is that you can take a backup. Typically, backup is an RDB file. You have an S3 bucket where you can copy that, give access to ElastiCache, and then you spin up a new cluster, and then you seed the data in the new cluster from the RDB file. And so now you have new Elastic cluster running with the RDB file, with the data seeded from the RDB file, and so you're ready to fail over. Now, for many of the cases, it works well because it's simple. You just have to take a backup, create a new cluster, everything happens, right? But your applications still have to deal with not having to use that cluster until ElastiCache cluster comes up and ready for you to consume. So many of the applications, many of the customers out there, they can't take that downtime. So what we did was recently we did something where you can do it in an online fashion, and that's what we want to talk about today. What does online migration does is that if you know Redis and even if you're not familiar with Redis, one of the things it does is that when you start a new ElastiCache cluster and when you start the migration, we actually start replicating data from your existing cluster that's not on ElastiCache in real time. And then you can also choose any instance type that you prefer in ElastiCache, particularly the ones that are extremely tuned for performance. You can choose any size, and we replicate data onto the new instance type, irrespective of the instance type you have on the self-service, self-hosted EC2. We have monitoring during the migration and after the migration. And we have let's say your application needs increased read throughput during the migration. You can do that as well. And in the end, customer is the one who's making the decision to say when to fail over. We don't make that decision. We guide you in terms of metrics, in terms of what to be done, but you make the decision as to when to actually fail over to the new cluster. And so if you have an application that can't deal with downtime, you can actually appropriately do it when it is the right time for you. And finally, you are going to be on the new engine version, 505, but that is the version that we recommend for all the customers. And the idea is that you are in a engine version that is tuned for performance, and you get all the benefits and innovation that we have been making on Redis that's separately from OSS. With that said, I want to show you how it works in terms of flow, and then we have a demo as well. For typical Redis application, what you typically have is you have a node running Redis, and you in EC2 or on premises for that matter, and you have a node.js app that's running, basically consuming Redis data using Redis API and providing the content. And you have applications, mobile applications or desktop applications using your node.js app to get the content and render it to your customers. Now, typically, customers who are hosting Redis, they run their workloads on their own VPC, and so when you actually start the migration, you go to our console, you start the migration. When you start the migration, before you actually replicate data, we want you to create an ElastiCache cluster in the same VPC. Why in the same VPC? Because connectivity is already established for you. You just need to give permissions to one of the security groups that we have, and so we can connect to your cluster to replicate data. Now, if you have a different VPC, you could do that as well. You just have to establish VPC peering, which is also simple to do, but those are the additional steps to take if you don't have the cluster in the same VPC. Now, once you start the migration, what we are really doing is that we're actually talking to your master in the on the EC2, and we're establishing a replication stream. When we have a replication stream, you are getting data from the existing cluster onto ElastiCache cluster, and so the replication is going on. And now in the ElastiCache cluster, you can have the topology that you prefer. You can have multiple replicas for that matter, but there is one replica, what we call primary replica. That's the one that actually establishing the stream and getting the data from your existing cluster on EC2. Now, at this point, let's say your application wants to use it, the new cluster for incremental read throughput. You could do that as well. Your application can call the new cluster endpoint and start consuming data from it, but you can't write because it's not a master yet, right? Now, once you're done all of that, and typically when you have a cluster on Redis, you can look at replication lag. The replication lag is the indicator that tells you how much lag you have from your master to the replica. Typically, the ones that we have on ElastiCache, typically it's 0, meaning your lag is nothing, right? And so you want to look at that data on your primary cluster, and then you make a decision to say failover. When I say failover, what that really means is that you are saying that I'm not going to be using the cluster that you have on EC2, rather your node.js app actually is using the cluster on ElastiCache. And so you have a fully managed cluster at the time available for you. Now, at that point, you can choose to actually retire your existing cluster on EC2. And so you have a cluster fully managed and running for you, and you have a primary that can take writes and reads at this point, and you can have as many replicas as you want. You can obviously scale out, scale in, or also scale up and scale down depending on how you're sizing your cluster, and everything is ready to go. So that's how, at a high level, the migration process works. Like I said, you have both options. You have an offline migration, which if you can take downtime, you can just take an RDB file, you put it in a S3 bucket, and you spin a new cluster in ElastiCache, seed the data with the RDB file, and you're ready to go. Or you can do it in an online migration fashion as well. You establish the cluster, wait for the data to sync, and then you make a decision when to fail over. And so you have a fully managed cluster for you. So with that said, Ravi is going to demo the migration itself, and we have a few considerations that we can talk to you after the demo. I think demo here, please.
Yeah. Yeah. Hi, my name is Ravi. I'm a software development manager with the AWS ElastiCache team. Oh, good. Sorry. My name is Ravi. I'm a software development manager with the AWS ElastiCache team. So let me just log in. Okay, so great. I'm just going to go to a this is your regular AWS console. I'm going to show you the setup first before I actually show you how the migration happens. So let's go to EC2, and then I have one instance running in EC2. So conveniently named Redis self-hosted EC2. It's running on an R5 large instance, right? And as Mohan was mentioning, it's part of a VPC, right? It has a public IP and a private IP too, right? So I will log on to a bit into the ElastiCache instance, to the EC2 instance, and show you the Redis database running there, right? And this is the Redis page on ElastiCache, right? And the instance, the cluster that I'm going to replicate to, the destination cluster is going to be Redis fully managed ElastiCache. As you can see, this is running version 505, which is the latest engine version that we have available on the service. And this also has a R5 large instance. Okay. So let's log on to the EC2 instance first and see the Redis database running there, right? I'm going to SSH to the host. So I just want to show you that it's the same IP that I'm connecting to, 381.62.121. Hopefully it's big enough and everybody can see it. This is the Redis client that I'm logging on to. Some of you are familiar with Redis, will be familiar with this tool too, right? So I can do an info replication to see what is the status of this particular Redis database. Right. So you can see that it's a master. It has no connected slaves. Right. Let's see some of the data that is there on this EC2 instance. You normally should not do keys command because it lists all the keys, but then since I have very little data here, I'm going to run a keys command. Right, so I have a few strings here. We can do get to see that. Right. So that's that. So this is my source EC2 Redis database. Now let's connect back to my ElastiCache cluster. This is the primary endpoint. Okay, let's copy that correctly. Okay. I'm going to connect to that using my Redis client. Okay, so we are on the destination cluster. Let's do an info replication here. You see this is a master, right? And it has two slaves. So this is a Redis cluster mode disabled cluster with auto failover enabled. I will show you that on the configuration, but you can see it on the Redis database too. Right? So let's do a keys command here. I have no data here. Okay. So this is the setup. What you actually have to do is pretty simple. You'll have to start the migration, and for that, select the cluster and you go to the actions. The actions table, actions drop down, you'll see migrate data from endpoint, right? And below that, you'll also see a stop data migration. So let's start it first. I'm going to give a private IP because we're in the same VPC, right? And the port, I'm not going to change the port. It's the default port that Redis starts on with, and it's the target Redis engine version, right? So let's start the migration. And once migration starts, you would see this has gone in from an available state to a modifying state. And this should take up a few seconds before it goes into a migrating state, right? You can also monitor the status of your migration by looking at events. So when we start the migration, we do send an event, and you can go to the events tab and see it. Okay? So let's refresh this. Just give it a few seconds to start up. Okay, now it's gone to migrating. You can see it here. Let's see whether we got the event for it or not. Okay, start migration. I did a brief test today morning. That's why you would see this at 9:16 a.m. So this is what we got now at 10:29. So it started migration. Okay. So what happens when it starts migration is that we make the a destination cluster, which you previously saw as a master, a replica of the master running on EC2. Okay. So this was my destination cluster, which I had shown you previously. Let's do an info replication one more time. Right. So the role has changed. Previously it was a master. Right now it's become a slave or a replica. Right. And then now let's try to do a keys command. Since we have very little data, it should have replicated by now. Right. You have the same 3 strings here. Okay, that checks out. And now since it's a replica, it cannot take writes. Right? So if I had to do a write, right, it says that you cannot do it. Right? Now let's go back to my source EC2 cluster and see what is the status there. Okay, okay. I'm back on 10:09. Okay, let's do an info replication again. Okay, what do I see here? I see the master, it's still a master, of course, but I see the connected slaves count has gone from 0 to 1. Right? I can also see the replication offset of the slave here. Right? I can see the master replication offset too. Right? So what has happened behind the scenes, as Mohan explained in the slide, was that we made it a replica of the master, we did the replication, and it continues to happen. Right? ElastiCache doesn't do an automatic failover. We don't make the decision when to make the source ElastiCache cluster the master. Right? It is for the user and the customer to make the decision when to sort of failover. Right? And what we recommend customers look at is the replication offset. And we also have a metric that we can show you. Right? This was the instance that is still migrating. Right? At this point, it means that you can still write to your source EC2 cluster, and that will still be replicating to the destination ElastiCache cluster. So let's get into that. Let's look at this. Right? These are the CloudWatch metrics that you would see for every node that is running on the destination ElastiCache cluster. I'm going to skip all of that. I'm just going to go to master link health status. Right? So you can look at this and see what is the status of health of the master as seen from the replica. And this has gone from 0 to 1. Right? So it says that I'm still connected and the master according to me is still healthy. Okay. Now you've seen that replication is happening, and as a user, as a customer, you decide to fail over. You want to make your ElastiCache cluster the master, right? What you do is that you go back, and then we started migration of data, you stop migration of data. Right. So if you have a small pop-up box here, which is to warn the users that if you're still writing to the source EC2 instance, then when the failover happens, there's a possibility of some data loss, right? The whole point that we are having online migration is that we want the data that is written to the EC2 cluster source to be replicated to destination. But when the actual failover happens and if your application is still writing to the source, there's a possibility some data would be lost, right? So that is the warning sign here that comes up, right? We just want to let the customer know. Okay, so that's gone back to the modifying state. So the configuration that we had done previously to sort of wire it up is going to be broken down, and the destination ElastiCache cluster is going to be made the master again so that it can start taking writes. Okay, so that's going to take a minute or so for our monitoring system to also make sure the right appropriate configuration changes are sort of taken in. Right. So while that happens, I want to go back to the slides. Yeah, some things that I want the customers to note and for you folks to be aware of is that we support only going to a destination engine version of 505. Right? Your source can be different, which is running on EC2, but your destination has to be 505. So online migration is supported only for the latest Redis engine version that we have. As of today, we don't support encryption enabled, that is TLS enabled. Our destination ElastiCache clusters, as of today, if we were to create a new ElastiCache cluster, you can have TLS enabled clusters. But for the online migration piece, we don't support that today. That is something that we are working on. And we already spoke about having the same VPC. Right? That's what the security group here means. In this demo, we had both the source and the destination the same VPC. If there are different VPCs, of course, you can do VPC peering. And multi-AZ enabled is, as Mohan mentioned, we have different configurations of our clusters. It can be cluster mode disabled or cluster mode enabled. Today, we support cluster mode disabled clusters, right? And with multi-AZ enabled, right? So we do support failovers of the destination ElastiCache clusters in case of problems even during the online migration. But Redis cluster mode enabled is not supported today, and that's something that we are also working on. So from the ElastiCache perspective, these are some of the things that you have to keep in mind, the engine version and the configuration of your cluster. These are some of the considerations that you need to have. These are per se not limitations with ElastiCache itself, right? But you just have to make sure you have sufficient memory in the destination ElastiCache cluster. This is sort of a no-brainer, but people may miss it, right? The second one is Redis by default comes up in a production enabled mode, which means that it only listens on the loopback address for request. You don't want that for online migration. It has to able to listen to other nodes too. So you have to make sure that is not turned on. Right? There is also bind configuration in Redis. You have to make sure that the source Redis engine version allows itself to take requests from other nodes. Right? That is what the second and third point mean. Redis also has option to rename commands. Right? So we do, if you rename certain commands, then we won't be able to replicate. We won't be able to apply those changes. So make sure you don't rename the appropriate commands that we use behind the scenes. And I showed a Redis instance. Redis instance can have multiple databases running, right? So we have to make sure that the source and destination have the same number of databases. Right? But apart from that, the migration itself should be just a stop and a start. Right? So can we go back to the demo? Okay, so your Redis fully managed ElastiCache was my destination. It's back to available status, so the migration has stopped. Let's go to the events. Okay, so this is what had started. Migration started successfully at 10:34. Complete migration was started, and then 10:36 complete migration was successful. So we completed that. Now let's go back to the Redis database and see how things are. Right, so this is my source. Oops, SSH done. So let me initiate another connection. This is my source, still a master. Right, and it has 0 slaves because migration is completed. Right. Now let's go back to my destination. Let me copy over the URL very quickly. This is the primary endpoint. Okay. Okay, excellent. So previously it was a slave during the migration. Now it's come back to become a master. And then it has 2 slaves connected to it, which is the 2 read replicas. Right? So let's do the keys command one more time. Okay, you have the 3 strings. Let's try doing a set, which previously didn't work when it was a slave. Okay. That works. You can get the command, and let's do keys one more time. Okay. So now we have migrated data from a source EC2 Redis cluster completely to an ElastiCache cluster in online fashion. And we also have it replicating to other nodes during the replication. Okay. Let's get back to the slides. Okay, so these are the three things that we mentioned that we are still working on. The demo that I showed you was with Redis cluster mode disabled. We want to enable Redis cluster mode also for the online migration. So that is one. The second one was the security aspects that I talked to you about that we don't support as of today. That is something that we're working on too. Right? And if you have workloads that you have on-premise, which is not on EC2, and you wish to migrate it to ElastiCache, we are happy to talk about that too. Right. With that, we still have like 15 minutes, so we can take some questions. I can have Mohan join me on stage. There's a mic up front here, so if you have any questions on Redis or ElastiCache or this particular feature itself, we'll be happy to answer that. Yep, go ahead. Please come to me. No, you can go ahead and start.
Can you sync ElastiCache clusters against other clusters in different regions?
Different regions you're talking about. Like I said, the connectivity is what it matters, right? So if you're in the same VPC, you have connectivity. If you have different VPCs, you have to do VPC pairing. If you do have different regions altogether, really what we are talking about is a public endpoint on the different region. Then we can migrate, but that's a special use case. Let's know what your workload is. Maybe we can take an action item to see whether we can make it happen. Yeah. Yeah. It's definitely possible. Not out of box, but we can look at connectivity aspects of the cluster that's running on the different region, on other region, and then we can guide you on that. Yeah.
And just to add to that, you're just looking at online migration of data from one cluster to another, or you want clusters working together in different regions?
Both.
Oh, okay, fine. So I think for the first case, as you mentioned, it is possible, right? Either you can have a public endpoint or you can actually do VPC pairing behind the scenes. The second one is more like a feature where you have multiple clusters running in different regions, right? Yeah.
That part got me because that was one of the things that Redis had at the expo. They were kind of
Yeah, stay tuned for our updates. So.
Yeah.
You have a question?
Yeah.
So when we do security patches, is there any downtime?
No. So that's one of the things we do. We take care of it in an online fashion. Particularly if you have a cluster where you have at least one replica, right? Then you don't have any downtime at all. It's all online. The way it works is that we actually add a node we call shadow node. We replicate the data, and then we take down another one. And then we also have technology where, for the time where you're making a failover, typically you're communicating with a DNS endpoint. And so for us to switch the IP from the DNS endpoint from old to the new one, there is latency involved, particularly on Route 53. So what we do is that for that duration, we have a small layer of software that's running on the new master, which is not fully new master yet because you have not realized on your client side yet. We actually take the writes and redirect to appropriate master to make sure you don't have any write loss per se. And so in net, you're not going to have any downtime in that configuration. If you only have one node only, meaning you don't have any replica, all you have is a master, then you are going to have downtime because even if we were to add a new one and do all the things that we need to do, still you are talking to the IPs directly, and for you to actually direct the traffic to the new master, it takes time for you. But many of the configurations, you absolutely have no downtime. One additional thing to mention is that you can go to console and say you want to do it now. I mean, you can choose when to patch it as well, and you get notifications and all that.
I'm listening to patching like in the November month.
Yeah.
So which was due, and it did actually show it will take like 30 minutes or so, but I told the whole team we might expect downtime on that. So, but it actually happened in like very quick.
Yeah.
It was quick, like in 10 minutes.
Yeah. So to patch a new node, it depends on the data size as well, because when we put a new replica and say, hey, go to the old master and establish a stream and get the data, depending on the size of the data, it could take time. That's the only thing. Everything else we do really fast. It's not a problem at all.
So you mentioned that you can only replicate to the latest version of whatever, 5.0.5.
Yeah.
Are there any limitations on the version of the source instance?
Um,
Replicate from an older version of Redis to a newer version. Are there any limitations on how old that can go?
The only limitations we have, there are a couple of things mentioned on the slides as well, is that your configuration of number of databases on that version should match the same number of databases on the new cluster. One important aspect is that you don't want to rename a command that we use. So if you rename a command on your source cluster, where let's say one of the things we call is psync and replica off and this thing, right? And if you rename one of those and we can't call those, then we can't do it, right? Those are the kind of limitations. But otherwise, it should just work for any version that you have. What version particularly are you running right now?
I forget the minor version, but 4 something.
That should be okay. That should be okay.
Yeah, there is per se no restriction. I think we in ElastiCache right now support from 2.8, right? So older engine version should work. Even in this demo, probably I missed showing that the source was running 4.0.
Yeah, you could. Should have no question.
Can you expand on the encryption part, like encryption rest, and this is for the migration only, or the cluster, the new cluster that is set up with ElastiCache is not for doesn't for migration.
So today, Redis open source, there is no encryption, as you know. And all you can do in terms of security is you can establish a username and password. We call auth tokens, right? That's what you have with open source. On ElastiCache, you have, if you want to have a cluster where you want to enable authentication tokens, then you got to also have TLS. So we believe strongly that it's a package. You got to have encryption and credentials to make sure your cluster is secure. We also enable you to actually rotate your credentials when they expire, and whatever the frequency you want, you can rotate the credentials. So the idea is that if you are running a cluster that's, let's say, auth-based cluster, and you don't have TLS or you don't have any encryption, whether it's REST or transit or whatnot, we don't want to allow that thing to migrate to ElastiCache. It's just that because we believe that it's a package deal, we want to make sure everything is together. Now, there are certain use cases where we could allow once, and then the customers repeatedly ask for enabling TLS after the fact, which is not possible, right? And so the only way we could actually make it happen is that if you have auth-enabled cluster, we migrate to you to our cluster without auth, and then we enable package deal, take auth and TLS together. But today, out of box, we don't support that because it's the complicated setup that you have to go through. But if you have a workload that you want to do it, let us know. We could actually whitelist and see if that can work for you.
You had a question? Yeah.
Yes. So in the case that we have like one primary node, the Redis, one replica, what happened to the failed replica?
What happens to, sorry,
Yeah,
failover?
so how AWS handle that case? If one replica fail, so how do you handle it? Is there any downtime?
If you have a primary, let me understand the question. If you have a primary and a replica on ElastiCache,
Yes.
right? And if a replica fails, that's the thing? Okay. So like I said, we have sophisticated monitoring. So we're always monitoring the nodes and see if the node is healthy or not. The moment you detect node is not healthy, a node is not healthy could happen for a variety of reasons. Either a node gets impaired because of a hardware failure or whatnot, or it could be that node is not responding because some situation on the hardware itself or in the software where you're consuming more memory than what you have in the box and it's not responding, right? In those instances, what we do is that we actually go ahead and replace the node with a new node and start replicating data. That is only for if you have one replica, right? If you have multiple replicas, you don't have that problem. You have other replicas, right? If you have only one replica, that's what we do. We replace the replica, we put a new node, start replication, it's available for you.
And at that moment, all of the read and write will go into the master.
Right. Depending on how your application is doing it, certain applications, they actually go for all the reads to the read replicas or replicas,
Yes.
and writes only to the master. And some of them actually do both reads and writes at the master. And so depending on your application can choose to say, well, my replica is not available anymore. So until my replica comes back up, I can just go to the master. You could do that.
So that is the thing that we have to do at the application or AWS handle behind the scenes. Like we're still using the same read endpoint, the same write endpoint, and no change on the application. You just like switch something on the back end, or the application have to do it by itself.
I mean, if your application is designed to only go writes into the master and
Yes.
reads to the replicas, then you have to change it. If you don't have it, you were sending, let's say, traffic for both master and replicas all along for reads and writes, you don't have to make any change. It should just work. It's just that your master is going to get more traffic than before because there is no replica out there. Does it make sense?
Yeah. So what you're saying is like we have to handle it from the application.
If you because you particularly if you restricted your traffic to go to master for all writes and reads go to replicas, then you have to make the change. If you don't have that restriction, you're just sending, hey, I'm just sending reads. I have two nodes, both master and replica. I'll just send it to one of the nodes, and I'm sending my writes to master. Then you don't have to make any change. Because replica goes down, your reads are still going through to the master. Now, in the non-clustered mode workloads, one of the things we do is we have a reader endpoint. And so for customers who are looking to distribute reads across multiple replicas, they can do that. You don't have to distribute anything. You just use one reader endpoint. We distribute ourselves among the replicas. So in situations where if you have more replicas and one of the replica goes down, then we know what to do in that case. We just put a new replica and add it to the same endpoint, and then everything is fine for you. But like I said, in your case, if you have code that's restricting reads to go to the masters, then you need to make a change.
Yeah, just to add to that point, you want to use the reader endpoint, and you want to have more than one replica or more than one node behind the reader endpoint, so that you'll be able to handle at least one node failure, right? And that way, your application doesn't have to change at all, and it'll be resilient to at least one node going down.
Yep.
Would you ever want to operate in a single node model with no replicas? Is there any benefit to doing that? Or would you always want at least one replica?
We encourage customers to use or at least have one replica for sure. The variety of reasons. One, you have better resiliency. When master goes down, you have a replica that we can promote as a master and you don't have any downtime. That is one reason. The other reason is that you have better throughput from your application. If you could say, for all my reads, I'm going to use my replica, and for all my writes, I'm going to use the master. So you have better throughput as well. We also encourage customers to have primary on one AZ, replica in another AZ. Particularly if you have availability zone that's experiencing some issues, and if you don't want to incur downtime, then you want to have your primary and replica placed in different availability zones, and so that way you don't have any downtime. So these are the kind of things we recommend. We also recommend customers to use cluster mode more than the non-clustered mode, because clustered mode provides you more options in terms of sharding data across multiple masters. In case if you end up increasing your data or your use case emerges in a way that you are significantly adding more data to that cluster.
As I understand the migration, when we do the cutover, our applications would need to, how do I coordinate that with my application's rights now needing to go to the new cluster, but the rights could still be received by the former master. So now I could have a split brain scenario. Do you have anything that can handle that? Any application proxies that might be able to help with that?
Yes or no. Once you are on the ElastiCache cluster, we do take care of that. That's the one I was talking about, where we have a thin layer of software that's running on the soon to be made master, right? And so, and also on the old one. So the idea is that typically what happens in a failover process is that you have a master and a replica, and when we promote the replica to a master, what we do is that we chain the DNS endpoint to point to the new IP, right? In that process, when the requests are coming, and on the client side, if you don't have the TTL properly set, then you could have still the old IP, and you still might be going to the old IP for writes, right? In which case, if the node is still healthy, you take the writes on the old master. New master that we are trying to promote is still not a new master yet in that case, right? What we have is a thin layer of software on the new master. If the writes come during that time where DNS hasn't caught up yet, we actually redirect the writes from the new about to be made master to the old master. And so you have one source of truth for all the writes. And once the resolution happens on the DNS to point to the new IP and client realizes the new IP, then all the writes go to the new master. Now, why I'm explaining all of this is that we can do all of that when you have your cluster running on ElastiCache. Now, if you have your cluster running in on EC2 and then new cluster in ElastiCache, we can't do that because that requires a lot more coordination between the old master and the new master, and we don't have that yet established because you could be running on an open source engine that's not compatible for us to actually do that collaboration.
Is there any software that could help us that we could run on our side to do something?
You could add client code that could detect or you could fork the writes in such a way that I have failed over, right? You made the failover happen. The moment you do the failover, you can say, I'm going to write the writes to both locations until you're comfortable that, look, I'm going to return this one. You could do that on the application. But I can't think of anything else.
Yeah, without a client-side change, it's going to be harder to do. You can think of certain proxies. I wouldn't pick a name right now for a proxy, but as Mohan mentioned, changing your client-side code to do dual writes is probably the best mechanism for that short duration.
Which many of our customers actually do that today because even though it's very small amount of time where failover happens, the case that is very interesting is that when you have too many applications to go update. If you have 1 or 2 applications, it's not a big deal, right? But if you have multiple applications, particularly if you have a bunch of containers out there that you take time to reboot, you do want to have code to have the rights for both masters until you're comfortable and say, look, I'm done with all the updates. Now, just return the old one.
Okay, I think we're just out of time.
Any other questions? No? Are we done? Okay. Thank you for your time today, and you can reach out to us. We have our emails on the slide. Even if you have questions about migration, or if you have questions about the service in general, please reach out to us. We would like to hear from you. We would like to improve our experience based on your feedback, and so happy to hear from you. Okay.
Okay.
Awesome. Thank you very much.
Thank you.